So because of this difference in speed, we are going to introduce a new term called as slip. Slip. So rotor speed is always less than the synchronous speed. The difference in speed is called as slip speed. So it is given by n delta equal to ns minus n. Ns is your synchronous speed. N is the speed of the rotor. So definitely this difference will always be there in an induction motor because it's an asynchronous motor. So this n del is called by a name called as slip speed. So slip speed is given by n delta equal to ns minus n. And the normalized slip speed is given by s is equal to, you denote by the small s. So a small s will be equal to n delta by ns. Our reference is always going to be synchronous speed. So divide n delta by ns. So it is ns minus n by ns, or it is 1 minus n by ns. So if I simplify, I can find the rotor speed in terms of slip given by ns n equal to ns into 1 minus s. Percentage slip means this value multiplied by 100% is going to be the percentage slip. So when the motor is not running, means capital N will be 0. Then slip value will be equal to 1. S value can never be 0, which means the motor is rotating at synchronous speed. When the motor is running at synchronous speed, Ns will be equal to N. So N delta will be equal to 0, or S will be equal to 0. But they say that S can never be 0 because the motor can never run at synchronous speed. Okay. For synchronous motors, you don't define slip. There is no term called slip because all are running at the same speed. But for asynchronous induction motor, since the two speeds are not going to be same, you are going to define a term called as slip. And slip can never be 0 because the motor is not running at the synchronous speed. In practice, what happens, the slip value is very, very small. Very, very small means the motor will try to run at ns, but it will never be ns. It will be running close to ns. So at no load, the slip is 1%, and at full load, the slip is 3%, which means that the motor will run always at 97% of your synchronous speed, or worst case, no load, 99% of your synchronous speed. So for the large size efficient motors, the slip is going to be only 1%. So the motor and the ns and n will be very close to each other. They will not be same, but they will be very close to each other. The induction motor almost has a constant speed. So n value, they say n value is going to be almost same. But even if you load or unload your motor, the value of n is not going to vary that much. Okay.